Right, so we're looking at a velocity versus time graph. Okay, we've got to calculate the displacement, and to do that we want to take displacement equaling average velocity times time. That means anywhere where the velocity is changing, we're going to take the change in speed or the height, divide it by 2 and multiply it by the time. In other words, find the area of the triangle. Okay, if we're dealing with an area like this one, okay, where we've got an object traveling at a constant velocity, then we just take the average velocity, which is the height of the rectangle, and multiply it by the base of the triangle, okay, and we've got our total displacement for those. All right, so all of our shapes, okay, look like this. So we've got a triangle here and a smaller triangle there. Okay, we got these two small triangles. Okay, this one here, which is only a half a second on the base. This one here, which is 1 second on the base. And then we also have, okay, this triangle here. Okay, we have this triangle beside it. We've got this rectangle and this little triangle here beside it. Okay, those should be all of our shapes that we need to calculate the areas of. Okay, the ones that you really need to pay attention to. So this is 1, 2, 3, 4, 5, 6, 7, and 8. Okay, would be 5 and 4 because their bases are fractions of a second. Okay, so triangle number 4, the time is only half a second, and triangle 5, the time is 1.5 seconds. So just be mindful of those two. Okay, everything else is a whole number. Okay, all right. So I'll give you a few more minutes to get those areas calculated. What do you need to do with all those areas when you're done to get the total displacement?
Add them.
Add them. But are some of them negative?
Yes.
Do you need to keep them negative? Okay, keep that in mind. All right, so here's what we're looking at. Okay, for area number 1, right, we've got the base of that triangle is 1, 2, 3 seconds. Okay, the height of that triangle is -3. Right, so we have the base 3 times -3 over 2. Everybody with me on that? Okay, so 3 times -1.5 should be 4.5. Right? I think so. Okay, 4.5 meters, and that's negative. Right? For area number 2, right, I'm looking at, again, a height of -3, but this time a base of 1 second. Right? So we have 1 second times -3 over 2, okay, which is going to be -1.5 meters. Okay. And then for area number 3, we have a height of 2 and a base of 1. Okay, so we're going to have 1 times 2 over 2, so that's going to give us 1, okay, meter. This time it's positive. Okay. Then we've got our rectangle here that has a height of 2, and it's 1, 2, 3, 4, 5 seconds along the base. Okay, so area 4 is going to be 2 times 5, which is 10 meters, positive. Okay. And then for area number 5, okay, we're looking at a height of -6 and a base, or sorry, I didn't do this area. I didn't number this one. Okay. I'm going to call that area question mark because I forgot to number it. So that's my bad. Okay, area question mark. Okay, that one's there. Okay, so now area number 4. Okay, my bad on that. Okay, area number 4 is the little tiny triangle that's base is 1/2, so 0.5. Its height is 2. Okay, divided by 2. All right, so 0.5 times 1 is 0.5 meters. That's positive. Okay, and then our next one is area number 5. Okay, area number 5 is this really long, skinny triangle. Right, it's it's on the base 1.5 seconds. Okay, and it is -6 high, so -6 over 2. Right, so again we're looking at 1.5. Okay, times -3. So we're looking at -4.5 meters. Are you all right with that one? Okay, and then area number 6, okay, another small triangle here. Okay, its base is 2 seconds. Okay, and its height goes from -2 to -6, and that's a common mistake that people make. They take it all the way to the x-axis, but its height is only 4, -4. Okay, -4 over 2 is -2 times 2 is -4 meters. Okay, and then we've got 7 and 8. Sorry, I'm just going to make some room here. Okay, so area number 7, right, we're looking at, it's a rectangle, so 1, 2, 3, 4 on the base, okay, times its height, which is -2. Okay, so we got -8 meters there. And then our last one is that little tiny triangle that is 1 second on the base and -2 high. Okay, so we're looking at -1 meter there. All right. So those are all the little areas. And yeah, that's kind of cumbersome and tedious and time consuming, okay? But in the end, none of that math is terribly difficult, okay? Me, with my math skills, was able to do all of that in my head, right? So it's not terribly difficult. Now I've got to take all of that stuff and add it together, okay? Rather than do that in my head, which would be a bad idea, okay? I'm just going to put them all in here, all right? So we've got -4.5 plus -1.5. Okay, plus 1, plus 10, plus 0.5, plus -4.5, plus -4, plus -8, plus -1. All right, so we got a total displacement there of -12 meters. And that makes sense. If we look at this graph, the object spends a lot more of that trip going backwards than it does going forwards, right? We've only got this small section of the graph here where the object actually has a positive velocity. That means it's moving in a forward direction, okay? The rest of the graph, okay, these triangles and whatever else, okay, they're all going backwards, right? So it would make more sense the object's displacement would be negative. It spent more time going backwards than it did going forwards. Okay, everybody kind of follow what we did there? Yeah? Questions from anybody in the live stream? Okay. So plan for today is this, guys. Okay, we've got a few more of these kinds of questions on the worksheet that I want to be able to work through kind of one at a time. Give you some time to try it, answer any questions that you have, walk through it together. Okay, because graphing's a super important skill for us to have. Okay, in Science 10. I know it's going to be a bit tedious, okay, but that's what I want to do is just go through kind of each one of these so you get a chance to practice, okay, and kind of perfect your skills. And if you have questions, then hopefully I can answer them, or they'll be answered when I go over it. Okay, if you're too shy to ask, okay, they'll be answered as I go over the question. But please don't be shy. Okay? Ask questions if you have them, right, so that we know what we're doing. There's a fair amount of marks on your unit exam to do with graphing. All right, so these guys are all in the digital workbook, okay? So if you're looking at the digital workbook here, okay, we just did question number 4, which is at the bottom of page 4, right? And now we're moving to page 5, okay? So we've got number 5 here with this shaped graph, which I'll put up on the board here in a minute or two. Okay, number 6, okay, it's a graph similar to the one we just did. Okay, it's a velocity versus time graph as well. Make sure you're always looking at what type of graph we're dealing with. Okay, and then we've got question number 7, similar. Okay, velocity versus time graph. Okay, asking you to do basically the same things. Right, and then you're not going to have to do number 8, so just ignore number 8. It's all those curves, and you'd have to draw those tangent lines that we talked about, and I said you'd never have to do. Since you're never going to have to do that, don't do number 8, because that's all number 8 is about, is tangent lines, so don't do it. Okay, and then number 9 would be our last one here, okay, and it's a position versus time graph. Okay, so you got to go back to remembering how do I get these things, or figuring out how do I get these things from a position versus time graph. If you finish all of that, then there's this thing. It says assignment, but it's not an assignment. I just forgot to change the wording. Okay, it's got a graph on here as well. Okay, it's a position versus time graph. There's a bunch of questions to do with it. If you get done those other ones, okay, we can have a look at that one as well. All right, so for now, let's start on page 5 of the digital workbook, question number 5. Okay, I'll put that one up bigger here Okay, and that's the one I want you guys working on here for the next little bit. Okay, so when I look at this graph, okay, without doing anything, just looking at it, okay, I see that this half of the graph that's all negative looks identical to this half of the graph that's all positive. So I just recognize from that pattern, okay, that the displacement here must be 0. Right? Now I can show that mathematically, okay, if I draw in those boxes. Okay, so you got these two rectangles, which are the exact opposite of each other. They're 5 times -8 and 5 times +8. Okay, so we got a -40 and a +40, and then we got our two triangles, which are also identical. Okay, this one's -20 and this one's +20, I think. Okay, but as you gain experience with graphs, and you just look at that graph and go, yeah, velocity versus time graph, yeah, this thing did exactly the same thing backwards as it did forwards, so it didn't accomplish anything. It must have ended up back where it started, okay, without actually having to prove it mathematically, right? I could put a question like that in as a multiple choice question, okay? A lot of people would spend a lot of time on that, doing work that they wouldn't necessarily have to do, okay? Does that sort of make sense? It's probably why I wouldn't do it that way. All right. So, your total displacement is 0, so that's part A. Okay, I'll give you some more time, okay, for average acceleration. Remember, we talked about this. This will help you with the average acceleration part. Okay, VF minus VI over T is our formula for acceleration. Remember that that came from this. Sorry. Okay, essentially, what you're doing for part B is you're calculating the slope of that line, but you're doing it with this formula instead of with m equals y minus b over x, because you don't have, you don't have b. That line doesn't intersect with the y-axis, right? So you would use this formula instead. Final velocity minus initial velocity divided by time. Okay, I'll give you a few more minutes on that before I actually solve. Okay, that's the formula you're going to need for part B. Okay, remember average speed. How do we calculate average speed? Total distance over total time. Okay, so you may have already done a lot of the work needed for that. If you actually did the math, okay, on calculating all of those spots, that'll be useful for calculating the average speed. Okay. All right, I'll give you a few more minutes before I go through the rest. So for part B, okay, they want us to calculate the average acceleration between 5 seconds and 15 seconds. All right, so we're going to be using, okay, this formula up here, okay, that calculates acceleration. All right, so VF minus VI over T. So I got to look for my final velocity. My final velocity occurs at a time of 15 seconds. All right, so my final velocity then is +8 meters per second. Right? I'm going to subtract my initial velocity, which occurs at 5 seconds, and that's -8. And this occurs between 5 and 15 seconds, so the time is 10 seconds. All right, so +8 minus -8 is +16 meters. Okay, here's why that makes, meters per second, sorry. Okay, so we go from -8 to +8. That is a change in velocity of 16 meters per second. Okay? I'm now traveling the same velocity in a forward direction as I was in a negative direction. Essentially, that means I doubled my velocity. Okay, or I changed my velocity by double what it initially was. Okay, and then I'm going to divide that by the time, 10 seconds, and I'm going to get 1.6, meters per second, or this is something I didn't talk about last week. We actually abbreviate meters per second as meters per second squared. Okay, that does not mean the number is squared. Okay, I don't want you to square your answer or anything like that. Okay, here's why we say that. It has to do with multiplying fractions or dividing fractions. Okay, so I'm dividing meters per second by seconds when I calculate acceleration. Is everyone okay with that? Right? The top is in meters per second. and I'm dividing that by seconds. Well, seconds is the same as saying seconds over 1. Now, if I'm going to divide fractions, I have to do what with my second one? When we divide fractions, we reciprocate or flip and then multiply. Okay, so when you're dividing fractions, you reciprocate, that is, you flip the second one and then multiply. Okay, what's meters times 1? Meters. What's seconds times seconds? Seconds squared. Okay, so instead of saying meters per second, we just say meters per second squared. Okay? And we usually just write meters per second with a 2 beside the seconds. Okay? Meters per second squared. That's where that comes from. Okay, so if you were looking at that and wondered why there was a 2 there, probably thought it was a typo. Okay, I meant to put it there. It means meters per second per second. All right, how are we doing with part C? How many people have done part C? All right, so let's have a look at part C then as well. Okay, so we want to calculate the total distance traveled. All right, so while I was saying that for part A, the total displacement, I might not show any work for that. I would just recognize that this thing does the same thing backwards as it does forwards and say 0. For the average speed, I need the total distance over the total time, which is going to require me to actually calculate all those spaces because direction doesn't care whether I went forwards or backwards. So that means, okay, we draw these boxes like we did before, okay, base times height. So 5 seconds times -8 is -40 meters. And then for this triangle here, the base is 5, the height is -8, -8 over 2 is -4, so this is -20, okay, and then the same thing here, okay, this will be +20, oops, I drew that in the wrong spot, and this will be +20, okay, and this will be +40. All right, since distance doesn't care what direction it is, I've got 60 plus 60, okay, for a total of 120 meters as my total distance, okay? And then I just read off the graph that takes 20 seconds for my total time. 120 meters over 20 seconds is 6 meters per second. No direction on that because speed is scale. Okay? I think I had that one on an exam about 4 years ago. That was an exam question. Right? Asked people to do those 3 things. Total displacement, which was at a 1 mark. Okay, average acceleration, which I think I made out of 2 or 3, okay, and then average speed over the whole trip, I think I made that one out of 5, okay, because they had to do the 4 areas and then add them up, okay, so that's exactly the kind of thing you could expect to see on a quiz, okay, or on a unit exam. Okay. Any other questions on number 5? Okay, so number 6. Okay, the graph's a bit crazy and there's no grid lines. Okay, so I get that can be a little bit confusing. Okay, just kind of do your best to approximate where everything goes. Right, okay, kind of like this. It's kind of far away, so it's hard to see. Okay, what time? I'm just drawing these lines in so you can tell what time all of these things end at. Okay, and start at. Okay, and then I think you guys can read the y-axis pretty easily there, so okay, just so you can tell on the x-axis where everything is. All right, so you're being asked to calculate the acceleration between A and B. Okay, so again, I'll write the acceleration formula up here. It is on your formula sheet, which is on the back of your periodic table. Now, if you're at home and you don't have your periodic table, that's why I wrote the formula up there, so you have it. Okay, but remember that it's also available in the classwork tab. You can always open it up, okay, on your phone if you've lost it or you're at home and you don't have it. Okay, that document is in the classwork tab as well. Okay, and then for part B, the displacement between A and E. Okay, so starting here and going just to here. Okay, for part B, and then the acceleration between F and G. That would probably be a 1 mark question on a test. Okay, and for E, the total distance traveled. So some of your work for B will apply to E. You'll only have to do a little bit more to finish that one off. All right, so I'm going to give you a bit of time, okay, and then I'll go through I'll go through A and give you a little bit more time to go over B, okay, and so on, right? And if you got questions, just ask, okay? Okay, so having a look at first A, okay, calculating the acceleration between A and B. All right, so here's the part of the graph that we're talking about between the two blue dots there. All right, so acceleration equals final velocity minus initial velocity divided by time. All right, my final velocity occurs at a time of 2 seconds and has a value of positive 20. All right, so positive 20 minus my initial, which was 0. Okay, that occurs over a time of 2 seconds. Therefore, my acceleration is positive 10 meters per second squared. Okay. Do I have to put the positive on it? Yes. Acceleration is a vector quantity. I need to indicate to people that this thing is accelerating in a forward or positive direction. Okay, because it is possible to accelerate backwards, and I need to indicate they're not doing that. All right. Okay, how many people are done B? Okay, so displacement between A and E. So I'm just going to erase all the crap that I drew here, okay, and put on some new shapes. All right, so I'm going to first look at that triangle there. Okay, then I'm going to have, this might seem odd, but I'm going to go all the way across to here. So I got one big rectangle, okay? And then I'm gonna have this small triangle and that rectangle on top of it. You may have drawn it a little bit differently, but as long as you've accounted for all the area under the line between A and E, you're good, okay? Because I know some people will draw like their rectangle just to like here, and then they'll have one big rectangle here. Same deal, okay? It doesn't really change anything. You're gonna end up with the same area. Okay, so we got area 1, area 2, area 3, and area 4 here that we have to calculate. Okay, so area 1, right? We're looking for the average velocity. That's going to be from 0 to 20, so that'll be the height over 2. Okay, so we're going to have our base 2 times our height 20 divided by 2. Okay, so 2 times 20 over 2 is 20. Okay, positive 20 meters. Everybody okay with that first one? All right. For area number 2, it's my big rectangle. It's got a height of 20 and a base of 1, 2, 3, 4, 5, 6. Okay, so 6 is the base times the height, which is 20. That's 120, positive 120 meters. All right, area 3, the little triangle here. Okay, so the little triangle it has a base of 1 second. And it has a height that goes from 20 to 40. Okay, so 1 times 20 over 2 is positive 10 meters. All right, and then looking at area number 4. Okay, so our other rectangle. It has a base of 3 and a height of 20. So 3 times 20 equals positive 60. All right, so we got 180, 210. Positive 210 meters is our displacement between A and E. All right. Keep those numbers because they're going to save you time when you have to do the last bit here about the total distance traveled, because you're still going to have these shapes over here that haven't been done yet. All right, give it a few more minutes here and then we'll look at actually, how many people are done C? Okay, why is C only going to be out of 1 mark on a test? Because it's 0. Okay, how do I know that? This is a recognition thing again, right? I look at this graph. I know that it's showing me velocity and time, and that between F and G, the velocity remains constant. Okay? Acceleration is a change in velocity over time. There's no change in velocity here. Therefore, the acceleration is 0. That's all I have to do. I just have to recognize that. And on a test, that's all I want you to do. Recognize that, and then I save you a whole bunch of extra work. Okay? Because you could prove that the acceleration is 0 mathematically, but I wouldn't require it. Okay? It's like trying to prove nothing. Okay? You can't really prove that. Or you can, but what's the point? Okay? So sometimes if you see a question is out of 1 mark, no, there's no proof required. Okay? Simply recognition. All right, I'll give you a few more minutes to figure out D and E. Okay? Remember, how do we calculate average velocity, just for this one? Okay, average velocity is total displacement over total time. So you got a little bit more calculating to do for the displacement up to and including F. Okay? The time's not too much harder to do. It's another 2 seconds. Okay, give you a little bit of time on that. Okay, so I'm leaving all these areas up because I need to leave them up to calculate the average velocity between A and F. So I still have a couple more displacements now that need to be calculated. All right, so I'm going to add on these 2 shapes here, okay, so that I can get my total displacement, which I need, over my total time, which is, to that point, 10 seconds. All right, so this triangle here, okay, which we'll call 5, and this rectangle we'll call 6. Okay, so triangle number 5 is going to have a base of 2 seconds and a height of 20 times 20 over 2. All right, so 2 times 10 is positive 20 meters for that. And then the rectangle below it, so number 6, okay, has got a base of 2 and a height of 20. All right, so that's going to be positive 40 meters. All right, so now I had 210 meters up to this point here, up to 8 seconds. So I just need to add on to that another 40, that's 250, okay, and another 20, 270. All right, so my total displacement to that point is 270 meters, and that takes 10 seconds, which gives me 27 meters per second. Okay, and that's positive. Or did it do?
I'm good.
Oh, okay, because you kind of gave me this look. You okay? Okay, so that's how we got the total, average velocity to part F. Okay, and then the last thing they want is the total distance traveled, which just means I've got a couple more areas that I need to calculate. So I'm going to extend this rectangle all the way over to here. We'll call that 7. Okay, and we'll call that triangle there, okay, 8. I know it's not very straight, but okay. So area 7, okay, is a rectangle that has a base of 2 and a height of 20, so it's the same as this one. 2 times 20 is another 40. Okay, so that'll be 310. And then our last one is that little triangle there. Okay, that little triangle has a base of 1 and a height of 10. Okay, so that's another 5 meters. Okay, so we said 310 plus another 5 is 315 meters. All right, so if we add all of this stuff up, we're going to have a total distance of 315 meters. All right, obviously I would never put one like that on an exam. Okay, it takes way too long. Okay, I can tell whether you know how to do this with one that has like 2 areas to calculate. Okay, and that's all I would need to know. Okay, this just tells me how fast you can do tedious work, right? And that's not what I want to test on an exam. All right, so this would be more like an exam. Okay, not as many sections, much easier, simpler calculations. Okay, wouldn't take you nearly as long. All right, so same idea here, guys. We're looking to calculate some accelerations. Okay, VF minus VI over T. Okay, we're looking to calculate some displacements. Okay, some speeds, some velocities. Okay, so keep all those formulas in mind. I'll give you a little bit of time to get through that one before I go over it. Okay, so part A wants us to calculate the acceleration between 7 and 9 seconds. So essentially, I'm using this formula here to calculate the slope of that line. Okay, how much and how quickly I change my velocity, okay, during that section. All right, so A is going to equal VF, which is 0, okay, because that's where this thing ends, is right down here at 0, minus VI, which is 3 meters per second. right? That takes place over 2 seconds, all right? So we're going to get an acceleration there of negative 1.5 meters per second squared. Okay. If I was to ask you, what is the acceleration of this object over the entire trip, what would the answer be? Requires no calculation. Simple. 0. Okay? Think about it. If we're looking at this formula here, VF minus VI, VF is 0, VI is 0, so our average acceleration over the entire trip is 0. Over the whole trip, the velocity of the object did not change. It started at 0 and ended at 0. Were there changes in between that? Yes, but over the whole trip, it didn't change its velocity. Okay, so little things like that to watch for, right? Those could be multiple choice type questions, right? I throw this graph up as a multiple choice question. What's the acceleration over the whole trip? People do all this work for nothing. Okay, it's simply a recognition thing. All right, how many people are done B? All right, let's have a look at B then. All right, so total displacement between 0 and 7 seconds. All right, so if we're looking at shapes here between 0 and 7 seconds, so 7 seconds is right here. All right, so I don't know, I think I would probably do something like this. You may have drawn the shapes differently, and that's okay. Okay, if you drew different shapes than me, I'm fine with that. All right, so we got area number 1, area number 2, area number 3, area number 4. Okay, so area number 1, we have a base of 1 times a height of 1 over 2. Okay, so that one is going to be 0.5 meters. Okay, positive 0.5 meters. Right, and then area number 2, okay, is our rectangle that has a base of 6 and a height of 1, so that's positive 6 meters. Okay, area number 3 is our triangle that has a base of 2 and a height of 2. Okay, over 2, so that'll be positive 2 meters. And then we've got our rectangle that is area number 4 that has a base of 3 and a height of 2. Okay, so that's going to be positive 3 meters. Okay, so we got 5, okay, plus, did I miss something? Area 2 is 6. I feel like I missed something between 0 and 7 seconds. Oh, yeah, I know what I did wrong. How come nobody noticed this? Why did I divide 2 by 2 on this one? It's a rectangle, dummy. Okay, so 3 times 2. I knew it was short somewhere in there. Just figure out where. Okay, 3 times 2. That one equals positive 6 meters as well. That's why it was short. Okay, so 6 plus 6 is 12, plus 2 is 14, plus 0.5 is 14, positive 14.5 meters. Okay? All right, how many people are done C? Average speed over the whole trip. Okay, I'll give you a couple more minutes on C and D, and then I will do those. Okay. And if you're done those, then you can move on to the next one. All right, let's have a look at the rest of number 7 here. All right, so for part C, they want us to calculate the average speed over the whole trip. All right, so average speed then is using this formula here, where I've got speed equals total distance over total time. Well, right now, I don't have the total distance yet. Okay, I've still got this last triangle that takes me up to 9 seconds. All right, so it's going to be area number 5. Okay, and area number 5 has a base of 2 times a height of 3 over 2. Okay, so that's going to be 3, positive 3 meters. All right, so our total distance traveled is 17.5 meters. Okay, we're 14.5 up to here. Okay, now it's 17.5. Distance and displacement in this case are equal because there's no backtracking. All right, so our total distance okay, is 17.5 meters. We're dividing that by 9 seconds, okay? So we should get 1.94 meters per second. All right, no direction on that because it's scalar. All right, and then lastly, they wanted us to calculate the acceleration between 2 and 4 seconds. All right, so acceleration starting at time 2 seconds, that'll be my VI. Ending at 4 seconds, that'll be my VF, okay? And the time will be 2 seconds. All right, so acceleration equals VF minus VI over T. VF is 3, VI is 1. That takes 2 seconds. 3 over 1 is 2, or 3 minus 1, sorry, is 2. Over 2 is 1, positive 1 meter per second squared. All right, how are we feeling about this stuff? Okay. It's cumbersome. It just takes practice. Like once you do a few of these, you get pretty good at it and you start to realize, all right, I got to do this, I got to do that. Okay, but we are going to spend some more time on it. Tomorrow, we're going to be doing a lab activity. It doesn't actually have a procedure. I'm just going to give you the data for this one, but it's going to be on velocity versus time graphs. So it'll be very much like the graphing lab we did before, except this time it's going to be for velocity versus time graphs instead. Okay. So guys in the live stream, that'll be in Google Classroom, and we'll live stream again tomorrow. Okay. So live stream guys, see you tomorrow. Okay. There's no quizzes till everybody gets back, just in case anyone was wondering. Okay. No quizzes till then. For the rest of you, let's get everything packed up, and I'll come around and spray your desks. So bye-bye, live streamers.